Good morning, friends. Welcome to my channel. Today I'm going to share with you the word problem involving distance formula and law of cosines. I made this problem myself. I want to share the problem that I've made. But first, let me share with you the quotes. The distance formula is like a politician. It promises to simplify things, but leaves you square rooting your problems. You know, the law of cosines is like a love triangle. No matter how you calculate it, someone always ends up obtuse. Now, this is the word problem. In a certain galaxy, an astronomer placed a virtual Cartesian coordinate system such that the origin was at star A. Stars X, Y, and Z were situated in the coordinate system with coordinates -1, +3, +2, -2, and +12, -1, respectively. Given that these three stars formed an imaginary triangle, what was the measure of the obtuse angle? Now let's have the solution A, the graph. So as you can see in the Cartesian plane, a point X represents the star X. Okay, so star X is located at the point -1, +3. Star Y is located at +2, -2. And star Z is located at +12, -1. So as we connect these three stars, X, Y, and Z, we can form an imaginary obtuse triangle. Okay, and then let us compute the distance between the star X and the star Y. So this is the solution. So take note that the first pair of coordinates is at star X. So x sub 1, y sub 1 is the first pair of coordinates, and that belongs to star x. So x sub 1 equals to -1. Okay, x sub 1 equals to -1, y sub 1 equals to +3. Then the second pair of coordinates, that is x sub 2, y sub 2, that belongs to star y. So that means x sub 2 equals to +2 and y sub 2 equals to -2. Now after the substitution, let us do the arithmetic. So as you can see here, 2 minus -1 is the same as 2 plus 1. So we have this expression 3 squared. -2 minus 3 is the same as -2 plus -3. So that gives us the expression -5 squared. So 3 squared is 9, -5 squared is +25. So getting the sum, we have 34. So the distance between star X and star Y is square root of 34. So if we want to get the, the actual distance, the actual measure, it is d equals to 5.830919. Okay, so this is measured in light years. Okay, d equals to 5.8309519 light years, because we're talking about the distance between stars. Now let us compute the distance between star Y and star Z. So this is the solution. So the first pair of coordinates, that is x sub 1, y sub 1, belongs to star y. And the second pair of coordinates, x sub 2, y sub 2, belongs to star z. So that means by substitution, we can say that x sub 1 equals to positive 2, y sub 1 equals to negative 2, x sub 2 equals to positive 12, and y sub 2 equals to negative 1. So let us do the arithmetic. So 12 minus 2, that is 10, and that should be squared. Negative 1 minus negative 2 is the same way as negative 1 plus positive 2. And that gives us the sum positive 1. That should be squared also. So 10 squared is 100, 1 squared is 1. Getting the sum, we have 101. So let us get the square root of 101 to get the distance between star y and star z. And to get the actual distance, it is equals to 10.049876 light years. Now let us compute the distance between star x and star z. So this is the solution. So let the first pair of coordinates x sub 1, y sub 1 belong to star x. And let the second pair of coordinates x sub 2, y sub 2 belong to star z. So by substitution, we have x sub 2 equals to positive 12, x sub 1 equals to negative 1, y sub 2 equals to negative 1, y sub 1 equals to positive 3. And then let's do the arithmetic. 12 minus 1 is the same as 12 plus 1. 12 minus negative 1 is the same as 12 plus 1. And that gives 13. And 13 should be squared. Negative 1 minus 3 is the same as negative 1 plus negative 3. So that gives the sum negative 4. And that should be squared also. So 13 squared, that gives 169. Negative 4 squared, that gives positive 16. And let us get the sum. So d equals to the square root of 185. So the actual distance between star x and star z equals to 13.601471 light years. And to find the measure of the obtuse angle, let us use this formula. C equals to the inverse cosine of this expression. Okay, so this is actually derived from the formula c squared equals to a squared plus b squared minus 2ab cosine c, right? So let us use this formula as a shortcut. So we know already the distances, no? The distance between each pair of star. So let us have the substitution. Okay, you can see the substitution here. So let us evaluate expressions in the left of the notation in first cosine. Right, so you get the quantity in the numerator, also get the quantity in the denominator. So if you divide the numerator quantity by the denominator quantity, you get the inverse cosine of the quotient. So the quotient will be 115.253 degrees. So this is the conclusion. Therefore, the measure of the obtuse angle is approximately 115.25 degrees. I am here another quote. I tried to use the distance formula in real life, but it told me, sorry, I don't deal with emotional distances. The Law of Cosines should be the official sponsor of dating apps. After all, it knows a thing or two about calculating angles and relationships. Thanks for watching, like, and comment. If you are new to my channel, please subscribe. May God bless you. Thank you very much.